uneven distribution, which lead reducing efficiency and environmental concern. And in addition of that, in the area of conservation agriculture, the presence of mulch
Recording in progress.
further elevate contact between soil and urea, which increase volatilization and nitrogen losses. So therefore, such a controlled investment we can address these challenges, but require specialized equipment like this to avoid nitrogen losses and overcoming mulch-related limitation and ensure precision nutrient delivery. These are the objectives of the research paper, including optimization of operational parameter of liquid fertilizer injection system under laboratory condition and subsequent development and evaluation of fit. These are the conceptual design comprised of the several key components such as a coulter dish to minimize soil disturbance, a liquid delivery tube for precise application, and this system comprises a compression spring to ensure flexibility of the system. The system is designed for uniform fertilizer application across 6 rows, ensuring effective nutrient delivery system. These are the we have made prototype of 6-row tractor operated liquid fertilizer system, and we have calculated that at top dressing need 87 kg of urea for this application. To achieve this, we prepared 5% urea solution by mixing 550 gram of urea with 950 gram of water. To make system, the system is now further calibrated to deliver at a rate of 1.63 liter per minute per nozzle, ensuring accurate, uniform and efficient fertilizer application across 6 rows, feeding this 87 kg of urea. These are our experimental plan. Even we have considered general urea, whatever we have recommended from agronomists. Liquid urea fertilizer is 100% of recommended dose. TC is 75% of recommended dose. And and if I control, that is, there is no urea in this case. So we have developed this machine, and we have conducted a field experiment. You can see below 100% general urea, 100% liquid urea, 75% liquid urea, 50% urea, and this is controlled. This is the working principle of liquid urea. This is the working video of liquid urea. First, represent the application of liquid urea fertilizer to field condition, and second is showing the application of prepared field to just check the flowing of liquid urea without any clogging. You can see that this is the spat reading. This is a cost treatment by rate of showing measure magnetic that improved nitrogen efficiency will reduce liquid urea 75%, 50%, maintaining high propylene content and effective nitrogen. A 25% reduction T3 match 100% efficiency. Even with 50% reduction in the case of T2, ensure sufficient nitrogen for healthy growth and promoting sustainable and optimized fertilizer use. These are some top attributes of plant population. You can see plant population, plant height. As per plant height, no significant difference due to limited force, just nitrogen effect. And there is no significant difference between T1, T2, T3 and T4. And in fact, there is a significant difference for that number of grain by yield, soil and harvest. So we can see that T4, which is 50% reduction in general urea, can perform at par with T1, T2 and T3. One of the problems we had in the application in real condition that achieving uniform application rate with a spraying machine. For instance, we can see that when speed is 0, there is still discharge is there. So, varying this speed, application rate also varies. So, we have to make uniform rate of application. So with zero speed, there is no discharge. To address this issue, a proportional control valve is installed between the pump and the distribution system. This valve regulates the discharge based on the speed of operation, ensuring a uniform application rate across the field. This regulation is guided by a predefined formula. You can see here to maintain uniformity throughout the application rate. This is the control for uniform liquid fertilizer applicator. You can see, and it incorporates a Hall effect sensor to monitor tactile speed and Arduino Mega to process real-time data based on this input a proportional solenoid valve. It integrated with its electronic circuit adjust discharge rate to match the speed of operation. This integration ensures precision over the liquid flow, prevented wastage during the stationary phases or speed variation. This combination of this technology provides consistent application rate, optimized fertilizer use, and improving operational efficiency and reducing any hazardous environmental impact. From this slide, we can conclude that liquid fertilizer applicator demonstrated a uniform application and reduced environmental. By 50%, we can see that saving of fertilizer is 50%, and we have converted into CO2 equivalent, and we have saved 60.5% CO2 equivalent as compared to traditional one. So the conclusion of my research is the water-based liquid injection system offers an innovative solution for nitrogen application, promoting cost efficiency, environmental sustainability, and optimized fertilizer use. This system has potential to transform nitrogen applications especially in the area of conservation and agriculture. The treatment T4 with a 50% liquid urea emerged as the most effective, achieving a 16% reduction in carbon equivalent compared to traditional method, while saving 50% urea without compromising crop productivity. Thank you. This is all about my presentation.
Thank you, Manish. And please, any queries from even forum the people present here or even online also?
Hello, sir.
Yes.
Next time.
No, wait here.
Is it audible, sir?
Yeah, it is audible and where you are? Okay, it is not related to this. Okay, Manish, say you please.
Sir, is it audible, sir?
Yeah, it is audible.
Okay.
Okay then, if there are no queries, we'll go to next presentation. Thank you, Manish. Thank you very much and good presentation. Very nice. Okay, next one.
Sir, myself is Avish Kumar, sir. Myself Avish Kumar Singh, sir.
Yeah, please share your presentation. Start.
Yes, sir. My screen is visible, sir.
Yes, visible and audible.
Yes, sir.
Hello.
Sir. Ready, sir.
Please, Avish Kumar, you start your presentation, but we are not able to hear.
Shall I start this?
Yeah, now it is okay. Start.
Hello. Good afternoon, everyone, and respected panels. My name is Avish Kumar Singh, and thank you for giving me the opportunity to introduce my PPT. The title is Innovative Raised Bed Pneumatic Precision Planter Enhancing Efficiency and Sustainability in Urban Farming. Currently, farmers are using a seed drill and a planter, just like conventional machines for sowing operation.
Introduction and all not required here. Go to the results
is
are
maintained.
done
However,
by
the plant-to-plant spacing is not uniform. The planters are also available because planted in inclined plates. The planters maintain the plant-to-plant spacing. The chances of mechanical damage are also possible. Pneumatic filters are also available in the market, but mostly are costly and not suitable for the small size tractor. For taking care of the advantages and disadvantages of the pneumatic precision planter, we have developed the pneumatic precision. It is a type of advanced agricultural equipment designed for planting multiple crops with a high precision while offering the added benefits of working on a raised bed system. This type of planter uses a pneumatic system to accurately place seeds at the optimal depth and spacing, enhancing crop yields and efficiency. Okay. So we have the following objective of the inventions. Raised bed pneumatic precision planter is developed, which has the following advantages also. Just like we can do the seed simulation for a whole seed, raised bed forming system, suitable for small tractors, uniform plant-to-plant spacing we can achieve, and the weed management, and it also helps in a hold to the moisture, and the raised bed saves the seeding in a waterlogging conditions. Okay. This is the detailed methodology of the proposed product technology. We have developed the components such as the raised bed forming, seed sowing unit, fertilizer applicator, depth adjustment wheels, mainframe, and as well as a 3-point system. The machines form the raised bed using the one formula, well-defined bed, and the seed and the fertilizer placement. It helps to improvise the seed soil drainage and aeration and to reduce the compaction. And we have the seed sowing unit consist of a seed box, seed metering, the pneumatic aspirator, PTO drives the aspirator, and generating the suction that lifts the seed from the seed box. So we have the novelty of invention, that seed metering unit that then control the seed flow, ensuring the accurate spacing. And we have the pneumatic suction lift the fertilizer from the fertilizer box, while the fertilizer metering unit controls the flow, ensuring the right amount of fertilizer as delivered. Furthermore, we have a metered fertilizer then delivered pipe that furrow opened the furrow opener alongside the about nearby 5 centimeter. And moreover, the depth adjustment wheels ensure the accurate planting depth by adjusting the height of the seed and the fertilizer. Okay. We have the silent findings of the developed planter. The developed planter can be operated by skilled and semi-skilled laborers. The planter can perform a raised bed making and planting of the seed in a single operation. It also helps to improve the singulation of the seed and reduce the seed losses by reducing the missing index by 1 to 4%. And we have achieved the multiple indexes by from in the range of 1 to 3%, and it also helps to reduce the labor cost by 30 to 60% in areas where the labor wages are high or the labor shortages are concerned. And the recommended achievable working pressure can be range from 20 to 15 kilogram per centimeter square depending upon the seed size of the crop. So we have achieved some data from the efficiency. The field capacity of the machine is 0.68 hectare per hour. Field efficiency we have achieved the 80 to 85%. Seed placement accuracy, seeds utilization, speed and productivity, and uniform depth and energy consumption. The approximate cost of the machine is around 18 lakhs. And user of the technology, the farmers and agricultural producers, just like a small
Thank you.
especially producers, as well as the agriculture enterprises corporations, commercial farm seed companies, and it also helps in agriculture service providers, just like we have the customer hiring services, and we can also give it to the institutions and agronomists, agriculture research stations, agronomists, and the government and the quality.
Okay, thank you, Avish. So, is there any queries on this? Yeah, that is Avish, is it purchased or made from your end? Because it is around 18 lakhs you have put, anyhow. That may be
Yes.
that may be the original cost or whether you have imported or brought from.
No, it is, so it is not the manufacturing cost. Manufacturing cost is around 3 to 5 lakhs. But overall cost of the project, the pressure gauge, the sensors that we are using for developing this machine, and we in the field and for the testing furthermore, the overall purchase of the equipment is around 18 lakhs.
Okay, nice. Thank you very much, and thanks a lot. And you can share your. Thank you.
Thank you.
Next one, please.
Sir, myself, P. Mahesh Babu, sir.
Yeah, please share your presentation.
Sir, it is all.
Yeah.
Sir, it is audible, sir.
Yes, it is audible at the full screen. Presentation mode.
Experimental setup for the development of a sensor-based
Presentation mode.
And I completed PhD in Calabasas College for Agricultural and Technology, Town. Sir, there is a reason behind that for selecting the engineer block. Total 50% of the production is the only three districts from Kerala. One is at Wayanad and Kozhikode as well as Idukki. These are three districts which is producing the 50% of the total production of the region. That is the main reason behind that. Then coming to the national work, India is a land of spices. So when you are looking to the crop, you are growing different acres as well as the tropical plant adapted to the cultivation in the tropical climate, such as iron. And the ginger is mainly used for the cooking to add flavor to food, as well as and the ginger is mainly an important role in Indian Ayurvedic medicine also. When the ginger is fully mature, it will get after 210 to 240 days after planting. So in market, ginger is a more market value compared to all other crops, which is raising the income of the farmers. The maximum seed rate of ginger is 1500 to 800 kg per hectare. So here. Before discussing of this side, we have to know the mechanical drawbacks as well as manual drawbacks of the planting. So when we return to manual drawbacks of the planting, that is less efficient, time consuming, limited
Mahesh,
production,
you please
as
go
well
to
as
your
manual These are the facing difficulties while manual planting. When we compare to mechanical drawbacks, so seed metal mechanism.
Mahesh, you please go to your work directly. You need not give all introductory things.
So please put the slide so sir. Hello sir. Sir, is it audible?
Yes, it is audible, but you have to put it on a slideshow. If it is not possible, you continue with that. Directly you go to your work, your development work.
It is requested to Mr. Mahesh Babu to lead with the screen on a large mode. His presentation mode. Thank you.
Yeah. Please continue. No. Kamraj, you please unshare your presentation for some time.
Sir, visible sir my slide?
Now you please unshare your slides.
Okay sir.
You continue, Avi. Mahesh. Mahesh, unmute yourself.
Right now, okay, sir?
Yes. You continue as it is.
Okay, sir. So this is my laboratory setup for the development of a sensor-based tractor in the plant. So this is the total length of the frame is 3 close to mm and width is 858. DC motor and seat motor control unit and then frequency drive as well as ground wheel and encoder and electric motor. So here the encoder we can fix at the speed of the ground wheel shaft. So in the ground wheel shaft when we are rotating the forward direction automatically count the number of pulses. The output pulses output signal sends to DC motor. Then DC motor it will run the meter mechanism. So then automatically the value is visible on the electronic control display. Then this is the components of electronic control system, which is these are the components which is used in the laboratory study. One is rotary encoder, which is the best effective method. It uses the traverse information. And next one is Arduino Nano. Arduino Nano for it is connecting the system to, and the Arduino Nano for exporting and importing the data. And as well as Citroen DC motor driver. The Citroen DC motor driver having power connection block from the DC motor to rotary encoder, and it's coming to LCD display. So when operating the in a lab study, in the laboratory or as well as in field condition, automatically the spacing it will be visible while operating, while in field condition. There is DC motor. So DC motor, the maximum height of the DC motor is 7 kgs and the maximum HP is less than 1 HP. So these are the block diagram of the sensor control system. First one is the mounted rotary encoder. We can fix at the speed of the ground wheel shaft. After that, we know the required seat rate, that is 1500 to 800 kg per hectare. After that, plant to plant spacing we know that is 15 to 20 centimeters. And microcontroller of control unit at mega G28 we can fix it at the middle of the control box. And pulse width modulation motor controller as well as DC motor. From DC motor output signal sends to the seat meter mechanism, seat meter shaft. So this is my laboratory setup for the development of sensor based operators in the plant. So I play the video, sir.
Mahesh, yeah. If you have any video, you please play it and then
This
go
is
to
my video, sir. Laboratory setup.
Okay, it is not playing here.
Because he is sharing the presentation, so we
Huh?
do not be sharing.
Yeah. Yeah. Full screen it full screen, otherwise it will not be shared. Yes.
First take present our presentation.
Okay, Mahesh, fine, you go to conclusion, not last slide. Concluding.
Conclusion, sir.
Yes, conclude.
Sir, finally, from the conclusion of this seat meter mechanism of building sensor based, the conclusion is indeed the properties of a ginger which helped in the design of the ginger plant meter mechanism and optimizing sensors are determined. So, there are considered three types of the sensors, that is 40 mm and 60 mm, based on the average size length with thickness of the rhizome. So, the main thing is the laboratory setup was fabricated and tested and values statistically was analyzed. Based on the statistical values, the study emphasized that crucial role for the seat meter mechanism in achieving the precise and consistent plant spacing for the ginger rhizome. And the optimized design and the operation parameters are proved to be a very good and effective method for proving an impressive of the 91.21% quality of the field index. So by using the sensor technology, it gives the precision work compared to manual as well as the mechanical drawback.
Okay, thank you. Thank you, Mahesh.
80.5 centimeter and missing index is 5. Okay, sir.
Okay, thank you for your presentation, but whatever, if any queries are there, then we'll ask you later. You'll be online. Thank you very much, and we'll go to the next presentation. Yeah, Kamraj, are you there?
Yes, sir, I am ready, sir.
Yes, please.
Sir, starting with sir.
Yeah, it is on your screen.
Sir, can I start?
Yes, please. Yes, you can start. Briefly, you go to your work and then you explain that and go to conclusion.
Okay, sir. So my topic is overcast single but subtracting machine with integrated image processing technology. So you know the history of this overcast. The sugar is grown in more than 115 countries.
No need of introduction, you please go to your work.
Even though the productivity is increasing, but the area is decreasing due to increasing seed and labor cost. This is a manual
You please go to your work. This and all, of course, now it is, we are running out of time.
Sir, is it audible, sir?
Yes, you go to your work.
Okay.
Your machine and its performance, or if there is any video, you please
Okay,
show.
sir. Okay, the first I developed engine operated sugarcane set cutter. So this is first I developed one. In this, the sensor is provided. So and the counter, the number of counts, the counter or timer is provided here. So the one video clip I will show that. This is engine operated set cutter. It's carrying the two blades. This is a timer or counter. So how many sensor cuts it counts. It's a demonstration. This is the farmers.
Kamraj, your video is not being visible here.
Video is not full, sir.
No, not.
Okay, sir. So in this machine, this the common stock is provided. So the two blades are in 30, 45 centimeters gap. So this ceilings are raised in the portrait. So in this machine, the efficiency is to cut 1,700 cents per hour. The cost of operation 1,000. The sales cost at a time around 90%. The cost of machine is 31%. So from this machine, so again I developed one semi-automatic sugarcane set cutter. In this no engine or power operated, only the battery is operated. So the DC models, DC models used here. So one is for conveying this sugarcane from the seed hopper vertically and horizontally. After fall down in the horizontal conveyor, it moves towards the cutting section. So after reaching this, the manually we have to cut this sugarcane whenever we need. This is semi-automatic. So here the partially automated. So from this machine, so I developed a fully automated with the help of image processing technology. This is a partial automation. This machine is a prototype machine. So here the red color, the blood is provided here. So from this dagger, the sugarcane is conveying from top to bottom. After reaching this here, then it horizontally moves towards the cutting plate. So in this machine, it can cut 1,300 sets per hour. The cost of operation 72 rupees per 1,000 sets. The cost of machine is only 26,000. So from this machine, again I developed fully automatic sugarcane separating machine. That is the image processing. It is other than this mechanical component. Here the DC motors and another one is the Raspberry Pi board is used here for supplying the power to the other components, and it's having the memory storage. Then next one is the Arduino board. It's controlling the all other components. Then here is a relay for time settings. Then the web camera used for capturing these buds. Then finally, this is the sensor. The two sensors here used the ultrasonic sensor and IR sensor. This is the isometric view of this machine. Here, sir, I will put the video, sir. Please.
Please.
Is this visible, sir?
No, not yet.
No.
Yeah, I think you are hyperlinked. Anyhow, if you
Visible or
have.
not, sir? Sir, my video is visible or not?
No, if you have a separate video, you run that. It may be visible here on your screen or shared screen. Yeah, he has to come out of that.
Okay, sir. So, the slide is visible?
Yeah.
Okay, sir. Here the cut reduction using web camera. So here the two DC modules provided. One is for conveying this material from top to bottom. Another one is here the sensors are provided. So when the horizontal movement of the super scans reach the particular point, it sends and gives the comments to the Arduino board. Then after before that, the 1000 images are taken photos. So 180 megapixels. So it's stored in this Arduino board. Then when this sugarcane is processed, then the image is capturing from the camera, then it's processed to the signal to this relay, and each and everything is working. So after reaching the cutting section, so the cam is provided here. So one cam, so with the help of this sensor is actuating. When the buds are reaching towards this center point of the two blades, then it automatically actuates and cut the cans. The results are cut to around 2000 sets per hour. That saves cost 84,000, saves the time 90%, 7 days is 90% in the field, the cost is 40%, 40,000. This is demonstrated to the our white chart, sir. So on 24/5/2024. Thank you, sir. Sir, I have the videos but I'm not able to show to you.
Okay, thank you, comrade.
Okay, thank you, sir.
Any queries? Okay.
Sir.
Yes, please.
So what is the cutting accuracy factor?
Yeah. Comrade, are you there in the,
Yes, sir.
what is the cutting accuracy?
This is the third place. So one more mark.
Okay, comrade, very good. Thank you very much, but we could not see your videos. Anyhow, thanks a lot. Good presentation. Next one.
Sir, let me start my presentation.
Okay, please go ahead, yeah. You share your,
Sir, my slides are this one.
yes.
Hello.
Yes, it is visible. You go to presentation mode.
Sir,
Yes, you go ahead. You go directly to your work.
Respected all the members, good afternoon to all of you. I am Vasu Kumar, PhD scholar, Department of Farm Power and Machinery, Dr. Padmanabh Vishwavidyalaya, Akola. I am going to present high precision calibration system for seed cum fertilizer drills. So, calibration is an important operation to optimize the performance of the seed cum fertilizer drills and planters. So, to reduce the error, we have developed a high precision calibration system to enhance the precision and the speed of the calibration of the seed cum fertilizer drills and planters. So the major components are offered metering system, shaft and collecting fan. So in the other electronic devices which are used are single board computers such as Raspberry Pi, rotary encoder to measure the actual speed of the metering system, stepper motor to drive the metering system, and road cell for measuring the seed distribution pattern. So the figure is showing the developed high precision calibration system and its major components are mentioned in the table. So these are the different design views of the system. So, the electronics component which we have used, the stepper motor we have used for rotating the metering system. Raspberry Pi was used to control the used as a central control unit. And the load cell of 600 gram capacity with a niche mount of 0.01 gram was used to analyze the seed distributor pattern in real time. And the rotary encoder of 5000 pulse per revolution was used to measure the actual speed of the rotation. And process flow diagram. So the Raspberry Pi is used as the central control unit of the system, and the Python language was used for the programming of the system. So Raspberry Pi will send the signal to the pulse width modulation signal to the stepper motor to control the speed of the stepper motor. And stepper motor will run the metering system. And the high resolution load cell was used to measure the seed distribution pattern in real time, which we can measure it in dynamic time variation like in 0.1 second, 0.5 second, or any time duration. So from low cell, from digital wave transmitter, so through Modbus communication we can obtain and gather the data of the size distribution pattern. And while the actual speed of the metering system can be measured by the row encoder. So the parameter we have used the forward speed, hopper level and active length in case of filter oil metering system. We can check any kind of metering system with the developed system. And the two major important parameters we are using the seed distributor pattern and the dynamic application rate, which are very useful for assessing the efficiency of the metering system. So for our system we have fixed the speed of the operation at 1 meter per second and width of machine 20 centimeter. So we can change the forward speed like in different RPM for variable rate application and then kilometer for normal simple and planter operation. So these are the data we have obtained in 0.1 second of the in each 0.1 second for the different kilogram per hectare at different RPM and hopper level. So our aim is to reduce this variation so that we can enhance the efficiency of the metering system and reduce the variation. So right now we can see that in each 0.1 second the variation is so high. So if we can reduce this variation, our metering system will be robust and it can be efficiently show the sheet at different RP speed and different hopper level. And this is the actual data we have obtained for the critical and major RPM with the indication we have later to the rotary motor. So as seen in shown in the graph, the as the speed is increasing, the little more variation is there in actual RPM, but it is not that much. So as a conclusion of the study, I can say that the developed system can be used by the research and manufacturer KVKs for providing seasonal calibration for the farmers. Thank you, sir.
The system efficiency itself is the 60%, and you are making it accurate to like 100% or so. It will make 60% accurate.
Can you hear the comment or request?
Sorry, sir?
Yeah. Now say whether you are you are shown that you could able to reduce the variation, but what is the final result and how better you could able to make out? If you are so-called gadget.
The forward variation everyone is checking, but it has assessed the dynamic application rate variation. So we are working on the different type of metric system to reduce the variation.
Okay. So you are working on that. Very good. Thank you. Thank you very much. Good presentation.
Thank you so much.
Okay. Next. Which number? Yes, please, you put it on presentation mode. No. Now it is fine.
Yeah.
First one. Fine, here you start your presentation.
Thank you for the development of mechanical transmitting system for the bigger unit. As you know that the bigger unit is known in the common region, which is having a very what is called the small antibodies. So considering that there is a need of for the small engine operated transmitting system. That's the need of this region, the small antibodies and the transmitting instrument and the great weight, and we are going to use a small engine for that. Considering that we have developed one transplanting system that is being used for the finger, but it can also be used for the vegetable transplanting. Now the contribution factors that we know that broadcasting system, breeding system and transplanting are there. But in case of the integrated transplanting is preferable considering its physiology. Now the general practice for the transplanting of the finger in this community is that they are supposed to prepare the wet line, then they have go for the preparation of the holes in the field, and that was this one second person drops that fertilizer in that cricket holes, and then the persons go for transplanting the irrigated seedlings into these holes. This is the general practice.
It is okay, go to your machine.
We have a different practice. The considering this gravity in the transplant system and the small land holding those is area, because the transplanting system small inefficiency due to the transplant system. The engine is the driver of this machine. There is a gearbox we use having the ratio 1:9 that supply the rotary motion to fertilizer giving mechanism. Then the gear wheels and the shifting filtering mechanism. These are the only one thing in the engine being used for this transmission system. This is proof that indicates how the transmission system is being used in this transplanter. Then these are the furrow openers made for this transplanting system. These are the rears and rear side. These are the rollers that structures are prepared. You can see over here also. These are the structures being made at the rear side for the covering of the seedling after the transplanting. This is the furrow being used for the opening the furrow. Then is it carousels being used for the transplanting of the seedlings at the rear end of the transplanted. The two persons are required for the seedlings in the carousel, and these are the cups in which the seedlings will be kept. There are two types of this carousels prepared. One is this cups carousel, the cups carousel. Everything of this machine. These are the seedling groups, dropping the seedlings up in the downside to the land. This is the tray for keeping the seedlings on the transplanting system. This is the fertilizer retailing mechanism. We are going to use the urea briquettes for this particular system. Then this is the point that indicates how the transplanting system actually looks. So here that fertilizer retailing mechanism here is the casserole. Here the seedling dropping tube. Here the furrow is there. Here the soil covering mechanism is there. Here is a small engine actually for this transplanting system. The intention for using this small engine which we use for the transplanter is that after the use of this fertilizer system, this transplanting system, you can remove that engine and then use for the other purposes, specifically for the transplanting. So that is the main intention of using this engine here. Here, you can see in here, there is a one tray being used for keeping the seedlings. This one is the handle for maneuvering this transplanting system. And at the rear end, the two persons will be there for putting the seedlings in the casserole. This is the actual machine. Here, and that is on the front side.
ये बहुत अच्छा काम किया है उसको और नहीं करता है सुगर के पास आटा बना के इमेज को बहुत अच्छा बना है
Okay, you please continue.
Yeah, these are the different observations age versus the speed of operation on these distances. So if you read this distance, you get affected, but in this case,
Okay, conclude.
not that much important parameter because we are not going to change the patent with this particular gauge. This is a parameter was tested in the pit whether there is some damage in the of these seedlings or not. For the purpose it is being tested. This is per square meter in the feet. Again, you can see that even though the maximum speed is not reduced now, the yields per square meter has got increased. These are some other parameters that were tested in the feet. And this is the operation, picture operation in the field. Here, one person, as it was very wet field in the beginning, that it was not working. So, one person has to pull the machine forward, and another person was working it at the rear end. And that was the very first was also the beginning of like this, and
Amit, please close your testing conclude. Conclude.
That the developed transplantation operates effectively at 0.5 km per hour operation speed, continuous seeding units seeding period. The total days of seeding age in the soil having moisture level between 18 to 20%. The cost of fabrication of transplanter was only 41,900 rupees. The cost of transplanting with the developed seedling was only rupees 19,270 per hectare compared to 39,700 rupees per hectare for manual transplanting. We realize that it should save transplanting cost by 35%. Thank you, sir.
Okay, thank you very much, Amit. Presentation was good. Thank you. Next.
Thank you very much, sir. Thank you.
Next, anybody?
Hello.
Yes, please make it very short. Within 2 minutes you have to complete. Of course, you put it in a presentation mode.
Sir, am I audible?
Yes.
Okay.
Don't put all this animation. You directly go to your work.
Okay, sir. The title of my presentation is Evaluation of a Planter having particular rotor with satellite metering mechanism for showing of control units. So, in this study, initially we have studied the basic properties of current leaf seed and followed by the laboratory calibration of the planter. The planter was developed by CIE Bhopal and we have evaluated it for planting of millet in Haryana. So, further, the field evaluation was conducted and this was the experimental plan. It was tested at 5 different level of forward speed and 3 different type of forwardness. And economic evaluation was conducted. So the engineering properties, we have measured this dimension, geometrical dimensions, velocity, moisture content, 1000 grain weight per nested envelope post. The calibration result shows the variation among the seed delivered from different forwardness, and the achieved application rate was around 4.1 to 4.25 kg per hectare. The variation among forwardness was in less than 5%, so it was in acceptable range. The field evaluation results indicate that as the speed increases, the depth of swing decreases. Also, the type of forwardness affects the depth of swing because the F1, that is the forwardness having 10 millimeter width, F2 has 30 millimeter and F3 has 60 millimeter width. The effect of forward speed of on quality fitness also so significant based on the increase of forward speed. Further, the effect of forward speed on type of forward on feed efficiency shows that feed efficiency decreases as the speed increases. Also, the type of forward affected the feed efficiency. The
capacity, weight efficiency, and fuel consumption. And we have set their level, and using the design expert software, we have optimized the result. So overall, best result of planter was observed at S2 speed, that is 2.5 km per hour, and 30 mm wide shovel type power plant. With observed showing that was 20.4 mm, which was very close to the target depth of swing, that was 20 mm, and quality weight index was more than 94%, with field capacity of 0.4 hectare per hour and fuel consumption of 2.97. The economic evaluation of planter was conducted, and the labor requirement was 2.5 man-hour per hectare, fuel consumption was 7.45 liter per hectare, and cost of operation was 765 rupees per hectare. These are the all factor interesting graph of that plant. So we conclude that the planter was calibrated, and the operated seed rate was around 4.1 to 4.2 kg per hectare, and the field performance result indicate that the speed of 2.5 km per hour and 30 mm wide shovel type was best for planting of permanent seed. Thank you.
Thank you very much. Swapnil. Swapnil. Thank you. Is there anybody here? Okay. Mr. Vijayarani, sorry. Mr. Vijayarani. Hello. Please unmute.
Yeah, I'll start, sir.
Yes. Put it on a slide mode, presentation mode.
Hello, good evening, sir.
Yes. Yes, you can go ahead. You just show your work and then go to this.
Soil and crop parameters in rice field rotation. So actually in the area of Punjab, Haryana and the western UP, there is a lot of main crime of this burning, and there was apprehensions that the super seeder may cause compaction, and so they have taken a 3 to 5 year study, and now we have data of 2 year study, and they have compared smart seeder, happy seeder, super seeder and the conventional method with field application and different soil and crop parameters were taken. So these are the 4 methods we have compared, sir. And these are the moisture content and the bulk density of different methods, and really find much of a difference in different layers of the soil from 0 to 45 centimeter of area. Here we can see the soil point index at different depth of soil after harvesting of the paddy crop. So we took data after harvesting paddy and also after harvesting wheat crop. So here you can see that, sir, in this case the happy seeder is causing more compaction than the super seeder, the smart seeder and the conventional method. Here we can see the soil form index at different soil depth for the after the wheat crop. So here we see that the super seeder is causing higher compaction. So the reason may be that it is a very heavy machine around, it is a 10 quintal machine, sir, and which is followed by the happy seeder, and then the smart seeder, and lastly the conventional method. So in the conventional method we are using we have used rotavator to harrow to cultivator to till the land, and then the seeder was used to sow the field. So here are the different machine performance parameters. We see that the super seeder is consuming 20 liters of diesel, maybe because it is fully incorporating all of the straw into the field, and moreover it is a heavy machine, that's why it is consuming more of the fuel. So here if we see the wheat crop parameters, we see that there is no significant difference among the yield of crops sown under different method. And so, sir, and the cost of operation also we see that the maximum is for the conventional sowing, because 4 to 8 operations are being conducted before the seed is sown. And in the other case of smart seeder, happy seeder, super seeder is just one operation. So we conclude that the yield is non-significant, and the 4 of them, the 3 of the method which we are suggesting, maybe the super seeder, the happy seeder, or the smart seeder they can be used by the farmer, and no such compaction data is seen for the first for the 2 years we have conducted our studies. Thank you, sir.
Thank you very much. Very quick presentation, good presentation. Thank you, Dr. Vijaya. And I hope we'll conclude this session. Coming to the end, of course, say the chairman, say because of the KP Singh has left the thing due to some of the other work. And coming to our presentations, all were nice but well prepared. This online presentation, totally 13 presentations were there. And in that 5 were direct presentation, the other 8 were online presentation. Thank you for patient hearing and being here. And all the people who are there online also, I really thanks. And one more thing is, because of the shortage of time, we have pushed you and then say they made you to conclude. Anyhow, thanks a lot and thank you for giving me this opportunity for the organizers and all the participants here. Thank you.
Thank you, sir. I thank both the chairpersons and the
Yeah, wrap up here, sir. So thank you very much for doing their work. Thank you.
So we are running short of time, so we have to start another session. So we are going to conduct 2 more sessions. So this is the 3rd session. So now with 2 minutes short break, we can start. So we have to arrange the session. So 2 minutes short break. Please.
Exchange time.
Dr. K. Agarwal, project coordinator, AICR,
Secretary, ICRCA Bhopal. Also, Dr. Sachin Nalwade, Professor in Gate, Department of Pharmaceutical and Power Engineering, College of Minerals Engineering, Naguri. So I welcome both the chairperson, Dr. K. Narwal. Sir. Dr. Gopal Carpenter, a scientist from ICRCA Bhopal. I welcome Dr. Gopal Carpenter. And also Dr. Sandeep, assistant professor, COE, then PDKV Akola. Welcome both the reporters. This session, there is no need for the presentation. You can directly go to the session. So this session is yours, sir. Thank you.
So good afternoon, everybody. Dr. Mehta, my teacher, Dr. Rahman, and all other colleagues from different parts of the country. This particular session is about harvesting and finishing machinery. And total 27 list. I don't know how many of them are present or how many of them are. Take attendance. Yeah, we will just first take the attendance. So first is Dr. Cesar. Online people also can raise their hands. He is not there. Then Dr. Tuteja or Dr. Nayak. Mr. Tuteja or Dr. R.K. Nayak. Not there. Okay. No, I'm just going one by one. That's why I was. Just one is Nisar Anand, Sunil Sirwal, Susan, anybody? Nine is there. Then Kamraj, Anita and Kevin. Okay, I'll come one by one. And Dhananjaya from PNU. Nobody is from PNU. Online also. Then from here, I don't know. Silence Tuppo, Satish, Devram.
Satish, are you presenting? सुबह मैंने एक प्रेजेंटेशन दिया स्मार्ट ट्रैप का नहीं
Dr. S.B. Pathak from Dapoli. Okay. And Dr. Manikandan is there. Engineer Sarveshwar. Imran, are you presenting? No. Your name also. Dr. Tyagarajan, Dr. Suren Kumar from PNU, anybody? Dr. Hydraulic Powered, Almira Equipment. And Santosh, Devanand Maxi, Uday Kumar and Anand Kumar. They were evaluation of air assisted electrostatic spin system. 8 years, इसमें आना नहीं था. I don't know how it has come. Harvesting testing. It is electrostatic spin system.
And plant protection is there. Plant protection, harvesting.
Oh, okay. from Ramanna C. Santosh Kumar, development of high clearance self-propelled chili harvester. And Dr. Deswana and Dr. Omkar Gupta is from here only. Dr. Thermite trigger pump separator. Swagatika Priyadarshini Mohanty and Raman sir. And Dr. Rajia Sarvan Kumar. Yeah, he was here. Not presented. Nene Vastevar ji, what is your?
He is there.
And Dr. Bangari, he was there. Dr. K.G. Dande, Ravi Kumar, Ajay Sharma. Is there anybody? Dr. Himanshu Tripathi and P.M. D'Souza. Anybody? And Dr. Palay. He was there. And Dr. Sudhakar from TNE. Is also there. He is sitting in the recovery.
So he will be coming.
Partner is double approved.
He is.
And Abhishek Jayasri Rudragoda from Karnataka. Ramesh Sandi is there. Mandirwari is also there. Okay.
Anybody from online?
Any online presenter who might have been missed?
One more. Your name is there?
No, your name is there here?
My name is there in orange.
Huh?
So you want to present?
Okay, you want to present? Just give your name. But here it is not there. Okay, we will call. We will call you. Huh?
I see the title.
So let us first call Jayab Singh, SK Singh, Manpreet Singh on development and evaluation of training system. Number 4.
So can I start?
Yeah, please.
Myself, Dr. Jayab Singh. I am from PhD KVK Sharpur. My study is on development and evaluation of baling system integrated with self-propelled combine harvester. Now this is the scenario. The 30 lakh hectare is under paddy and more than 20 million tons of paddy straw is there. There are different straw management, whether it is in situ or ex situ. This is the case of conventional combine harvester. This is the, you can see in second picture that there is a straw that is left behind our combine harvester that create hurdles in the direct sowing of wheat. These are our objectives to develop and evaluate this self-propelled combine harvester with baling attachment. I will skip the review of literature. I will come to the how is it, whatever the straw that is coming from the straw worker, baler attachment should be there so that the loose straw that is coming to the ground should be baled effectively. This is the development model, how this model comes. Now these are the different developments. We have to detach the behind portion of the combine harvester, then to attach it. Then in figure 5th, we have to transmit the power from the combine harvester to the baler attachment. These are the two different views. And we have to develop a flat belt conveyor system which effectively conveys the loose paddy straw from the combine harvester to the baler attachment itself.
separately claimed.
Complete
Your presentation and that is last.
and then last we can see that. That will be better if you.
So now this is the system that is these are different independent parameters, that is forward speed, flat belt, conveyor system, and the different paddy varieties that having a different straw load. These are the different that is a paddy variety have different straw loads. This paddy variety that have significantly effect on the straw worker seed loss, as there is no significant effect on the cleaning efficiency and significantly affect the fuel consumption. As forward speed, different forward speeds, it significantly affect the straw worker, seed loss and cleaning no cleaning efficiency, while the fuel consumption. Why different at different belt conveyor speeds? We have a different straw worker loss and seed losses effect on the cleaning efficiency, no fuel consumption. Based on the different effects, what are the best suitable parameters having minimum straw worker loss, minimum seed loss, and maximum fuel consumption, that is F1B1, F1B2 and F1B3. This is something that is paddy variety affects the different dependent parameters. Forward speed also affect the straw worker, seed loss and fuel consumption, and best operational parameter that I have discussed. I will only show the field video. Please click folder में होगा.
Then you operate it. Which one you want to operate?
Sir, this is the combined harvester. It doing two operations: harvesting as well as baling of the paddy straw. That is the straw that is coming from the straw workers. As the loose residue creates hindrance in the directly weed sowing, whatever the straw fall, that is only the seeds. After doing this, there is only anchor stubbles and there is no much loose straw. We can just go for direct sowing of wheat with zero till, or we can do a rotavator or simple conventional seed drills. Because the paddy straw burning issues comes from the harvesting itself. If we just manage the loose paddy residue, we can manage the paddy straw effectively. This is the basically our system here. Whatever this system is also operated for the wheat, it also effective for basically wheat as well as for paddy crop. Limitation I will also discuss, that is during the paddy harvesting there is almost moisture content of about 50%, but during wheat it is only for 10 to 12%. Whatever that is that there is that for high moisture content we are only use that rectangular baler, and this much for loose straw. I have also considered fermentation of urea treatment. Whatever the urea treatment, it will do three operations: fermentation, then it's harvesting and paddy baling. After 9 days or 10 days, this fermented bale can also be effectively fed for different milk animals. Thank you very much. If any questions, we can raise. Yeah, I have tested for only two crops, that is paddy and wheat. Sir, I will have tried for wheat crop. This is that for wheat harvesting we operate straw, that is our chopping straw, wheat straw combines. In wheat straw combines there is lot of much dust concentration. Yeah. Yes sir, yes sir.
Are you aware that commercial combines are also there with baling system? Myanmar has developed.
Sir, can you speak sir?
But in India it is not available.
Yes sir. Yes sir, yes sir.
Earlier by introducing eastern part of our country, nearby.
Basically, from the review of literature, these type of bearing attachment is itself in China, crack type combines. But in our Indian situations, we have a tire combines as self-propelled or tractor operated. Then we have developed this system so that effectively harvesting as well as wheeling can be done consecutively, simultaneously, sir.
This is your PhD work.
Yes, sir. Yes, sir.
So, what I was expecting that what happens to that bale? What was the output? That thing should have come out. How many bales you are getting? What is the compaction level of bales you are getting? You know, how much straw you are able to gain and how much straw is still there. That you are showing that in the video itself, the lower part of the straw is still falling. Straw workers straw is coming to bale, and the rest of the straw is coming down. So you are not able to collect 100% straw. It's only 60, 70 or 80% maximum. So that part should have come.
Collection efficiency is not mentioned, and one thing my question is that how much is the weight of that total system we are adding there, and what was the effect of that on maneuverability of that combine?
Yes, sir. Future work is that that is lot of weight is put on the rear part of the combine itself. We have to develop a lightweight. Dr. Agarwal's I will answer that due to high moisture content, the weight of the beer is around about 20 kg, 20-25 kg. But in conventional case, its length is about 2 to 3 feet. But I have done to half weight so that weight can be there. Second limitation is that high moisture conditions. I have also done heat given to the straw, to the pedestal that is on the straw worker, so that somewhat moisture can be wave off. Then this lightweight system has to be developed.
Please keep it. I am not
Okay, sir.
which you are doing it.
Thank you very much.
Now, thank you very much. Now, I call upon Dr. Manikandan. Please try to keep it short. Don't spend much of time on introduction and other things. Go straight away to
Your time starts now. 5 minutes.
Yes, please. Yeah, please.
Myself, V. Manikandan from CAA RS Coimbatore. My topic is performance evaluation of tractor operated hair. Hair is for gather and train the hair into rows and easier drying and collection. This is the most of common of hair. In hair, different rotor, tines and wheel for supporting of the total unit. Windrow hard for collecting the straw in narrow space. It's a field evaluation of hair. The field evaluation after combine paddy harvester, you field evaluate the hair. This machine tested also sugarcane field also. This is a field operation of hair. The hair rotary rotate 100 RPM. Collect the straw in narrow patches. This is used for easy for making base. In field development research, the average length of straw 830 mm. The forward speed of operation 2.81 km per hour. The average working with the rack 2435 mm. The area covered hectare per hour 0.55 hectare per hour. Time required for covered 1 hectare for 2 hours. Fuel efficiency of this machine 81%. The fuel consumption also measured. The fuel consumption liter per hour is equal to 1.83. Fuel consumption also calculated for hectare also. 1 hectare per hectare is equal to 3.48. Loose straw per square meter. Before and after, the before hierarchy 2.4 kg. After using hierarchy 0.04 kg. In that case, trash lighting efficiency 98%. This is a conclusion.
Within 1 minute, say concluded.
The cost of the machine around 1.3 lakhs. Santosh agree.
Any questions from audience? I have one question. What is the smallest feasible size of the field where it can be used? Smallest size where it can be used. So what would be the feasible size? So mostly if you are not studying, at least where we can go for feasibility. Where it is feasible. Cost wise, it's a very big
popular in Tamil Nadu. Bailers and Kiskeya, both are combined.
1.5 meters? Size?
2.4 meters.
It is commercial.
The average width of operation 2.4 meters.
My only suggestion is that please check the fuel consumption.
Yes, sir. Direct loading.
1.83 discouraged. 40 HP. 40 horsepower का भी ट्रैक्टर नहीं आइडियल में भी नहीं होता.
So thank you very much, sir. This discussion will go on. That's it. Next.
Very good afternoon to respected directors, CI, Dr. C. M. Mehta. Most respected, in today's presentation is available my teacher, my guide, and I can say my mentor, Dr. H. Rahman, then the jury member, my colleagues and my dear friends. So today I will be talking about some of the initiative that is we have taken in a external funded project for mechanized tea leaf harvesting. It is a externally funded project. 4 partners are there. I will concentrate on only the vehicle development part. Other parts I will skip it here. So you can see that 2 photos I have pasted it here. This is commercial tea leaf harvester that is generally available. Imported one. It is only one is available in India. That is imported from Japan. It is almost 55 lakhs. And we are trying to develop a indigenized one here. So here generally probably you might be that in tea only 2 leaf and 1 buds are harvested for proper tea processing. So we are trying to here mechanize or as well as automate economize to harvest two leaf and one pod. So these are generally nowadays it is almost 100% manually harvested, and almost 67% of the labor is required for harvesting in the production cost of tea. So these are the problem. I will skip it here. So these are the options available for blocking. Basically, already have said the donor blocking. Generally, these kind of blocking preferred when there is a overload. Overload means after July, approximately there is a huge amount of loss is there. So the manual force available, manual labor available in India is not sufficient to block all the leaves. So that's why at that time the tea planters are prefer this kind of to reduce their huge losses. But these are generally they do not prefer. So these are the planting geometry, you can say. Here you can see large drains are there. If you go for mechanization, then we have to eliminate this kind of drains because any vehicle cannot overcome this kind of vehicle. But the gap you can see it here. Here only about 300 mm gap is there. It is a almost woody stem is there, and woody stem, but it is very much fragile. If there is a little bit strike is there, then it will break. So we have to have consider, and you can see the height not more than 300. But for mechanization, we have to have some channel. We have modified at Jorhat 1 hectare of field to accommodate the mechanization there. So these are the objective: a remote controlled, self-propelled driven platform. Because it is the first part. Otherwise, if we will be succeeded in harvesting, then we will go for unmanned kind of vehicle. That's why we have go for hydraulic kind of system. Then after harvesting, there will be storage handle will be there. Then hydraulic tipper or empty stopper. Then selective tip. I am not discussing because this is part of the Sedan Kolkata. So I have gone for the design vehicle. It is a self-propelled vehicle. So only the rolling distance is required to overcome the overcome. So that's why we have calculated. We have gone with the classical vehicle, off-road vehicle machine design, where the tire we choose what is the narrowest tire available in India. That is 8.320, 6 flight rating, and these are the all the capacity. So design criteria that the vehicle will just climb a desired slope. This is the most torque requirement without slipping under desired condition. And second, the most important condition that if it is running over the slope, sometimes its engine stopped, then some sufficient starting torque should be there, so that it can maneuver and it can overcome that the gradient. So these are the basic all the pharmaceutical people you know that I have gone through the Whitmore Loop 1972 available. Now that Brixius is updated one, it is around 2000. So accordingly I have calculated because what is the torque requirement at the wheel only. It is a self-propelled one and two-wheel drive. So I am not discussing only 921. These are all four conditions are there. What is the maximum? Then one thing I just forgot to say, it is a completely hydraulic vehicle. Because we have come across many tea garden in Jorhat. There the plantation varies from field to field, planter to planter. So to accommodate, they have the need that we should have the adjustment of row width. Height we have not considered because the picking height generally varies from 800 to 1100 mm. So we have not considered, we have kept the maximum. But power requirement we have calculated according to the traction theory. We calculated that 70 kilowatt is here 22 HP power is required. So accordingly we have designed the complete gear model. And these are the hydraulic circuit. It is generally hydraulic transmission as well as all these systems are operated through the hydraulic. So these are open loop and closed loop systems are there. So this is steering system. This is for some other the vacuum operation. This is the transmission. All things are available. Then this you can see this is the core part of that. This is a servo controlled closed loop axial piston pump which is operated getting power from a tractor engine. And operating, there is a closed pedal. Through the closed pedal, we are steering and also differentiating the vehicle. So this is the power steering is there. So a cooling system because closed loop hydraulic system is there. So this is the you can see complete assembled vehicle. These are the parameters. I am skipping it here, already have said. Then you can see the already we have taken it. It is developed at Bhopal and we have taken it to Jorhat. So it is the field at Tea Garden of Jorhat. So we have developed it. Many parts are there, but as already I have said, my part is only the vehicle design. So these are this is not as per our their design. Other institute is looking for it. So we are modifying. Still the project is running. So vehicle already I have handed over to them. So they are doing all of the parts. This is from from my side. Thank you.
Any query? Anybody?
Generally, it not daily basis. Actually, 40 kg and in an average 20 to 30 kg a woman crop. Generally, women laborers are there, women crop, and they generally their system is different. The tea planters are providing all kind of facilities. All kind of facilities means housing, water, foods, all everything, and they are paying 180 to 240 rupees. Beyond that, and for 20 minimum 40 kg. Above that, if you go for 10 per kg, they will be provided. They will be charged more.
Actually, I have one question. Why that manual machines are not being used?
Already I have said, sir, tea is selective procurement. For a good leaf, a good tea, you might have heard that the leaf count, good leaf count should be 55%, 55 to 60%. If it will be more than 55%, then it will not be categorized as a good leaf, a good tea. It will be a medium category tea. Then more than that, so if it will be a shear cutter, then there will be not selective, it will be complete. There will be not the actually so-called banji leaves are there, the dead leaves are there, all leaves will be there. It will not be segregated. So it will be a medium quality or low quality tea. So
again, this machine will be having same problem.
No, already this is selective quality. Already four institutes are there. The SIDA Kolkata under Ministry of
So you have not covered.
No, I am not covering. I am not covering.
It's okay.
Thank you.
Development of high clearance self-propelled chili nuts.
So good afternoon. So I have seen the previous experience. I just go through. So we worked on high clearance controlled chili harvester. So even today in India, chili harvesting is done by manual 100%. 100%, even though it is commanding around 1.68, 1.7 lakh hectares. So we are still going ahead with this. So, yeah. Of course, this and all, it requires around 100 people for harvesting one hectare of the land. And of course, we have developed and this and all, say, just I'll avoid. Yeah, this is also, as my previous speaker was telling, this was a high clearance setup which we have developed exclusively. So previously we had some other task, and now So we were working on this, and this high clearance task, this thing we have used, and Komodo small stage tractor we have used, and of course helical rollers we have used. So counteracting helical rollers, and these dimensions are like this. So this just I would like to tell, this is a high clearance setup. This is the tractor which I have used, and this is the helical rollers say, running opposite direction, which was actually mounted in the high clearance this thing with a hinge, not actually fixed. So the why it is means say of course we have taken a power from the PTO, and say to have a counter rotating rollers, we have done some designed this thing, and of course for better visibility we have designed what do you call it, camera, and as well as its image to the operator. So this is this thing, and this adjustment is for achieving the height, because on the road we may need to raise the entire equipment, and in the field we have to lower it, because the chili plant from the beginning there will be a parts. So this is what my equipment they design, and this is the equipment which is there in the what we call this thing. Coming to initial trial. Okay, will show the last. So generally we have tried with the 1 kilometer per hour forward speed, and as well as 2.2 kilometers. So which was having only harvesting efficiency around 60, but afterwards we could able to develop and do a lot of maneuverability, and finally the harvesting will be better, but the collection which is a little lower side in the trough, whereas in the center where we will see this view. Completely done, but in the center there was a drop. That's what I have shown. The correction ability is only around 58%. We are working on that. Actually, if I get any what you call manufacturer, then I would like to incur money on that. So the people, because just spending on that, the university doesn't have much money. We have used our own resources, and we could able to develop. So thank you very much. If you have any doubt, we can say disclose. Because I have just rushed it through, because I know the time constraint. Thank you. Is there?
Effort made by you are very good. We appreciate it.
Thank you, sir.
One more thing in investment that we develop at copper plant, Vega
Sir,
from that.
No, sir. Actually, this is completely my design. So he started in the vertical rollers. You also might have seen. So then after the
What status of that?
was dropped. To be honest.
has taken that problem around 10 years.
Yeah.
And it was also funded by some external agency.
Yes. I know that they have made just, they said that after getting this was on the pipeline, then they said that the Ramana sir is doing, so that's why I am talking.
But we have to work in this area
Yeah, actually it is working well.
Even
If
some attempt has been made at IIT Kharagpur also for development of self-propelled.
Sir, my submission to the house or all the young trucks are there. So let us not invent these already organized way we have, like our tractor. Tractor we cannot design and again do it. So try to utilize those kind of the prime movers for our application. Because it is well designed, it has got all the components, you try to utilize. If it is required, then you can have some addition.
I have one question that
Yes.
you have raised the tractor
Yeah.
to a certain
Yeah.
height. So is there any issues regarding CG of that vehicle?
CG
while
was-
traveling on the road and while transferring to the field,
Yes.
there will
Yes. So actually, sir, to be honest with all the people, this is a three people thesis. So the first one, it was done only on the high clearance setup. So high clearance setup for the intercultural operation in the cotton, which we have done. So in that we have done all the studies which you are mentioning. The CG and stability, everything we have worked out. So the same thing we have used, and similarly the chili harvester manually operated, electrically operated we have developed. He is also under my student. So which is not feasible in our field. That is why we made it into the high clearance set. That high clearance part and this double roller part, and we have made it as an integrated. Thank you very much. Thank you.
Next is Dr. Vastav. No, sorry. Swagatika. Please, Vastav.
Good afternoon all, respected panel and professor. So today I am going to present the topic effect of electrostatic charging, forward speed and drop canopy depth on the droplet size distribution of an battery operated self-propelled electrostatic sphere. So there are several drawbacks of any conventional sphere. So I am directly coming to the methodology of the current study. So to fulfill the current study, first a single electrostatic unit was developed and it is presented here. So there is a spare body and copper ring was used for charging the spare droplets, and there was a DC reducer converter which was used to to amplify the voltage from a DC battery to the required amount of DC voltage. And this is the design and development of the self-propelled electrostatic sphere. So for that, first as I mentioned, the single electrostatic spraying unit was developed, and after that the spraying system was designed, from which the what will be the size of the pump and the number of nozzles, those are decided. And third was the design of the battery unit, that means how many number of batteries will be required to carry out the spraying operation. And fourth was the design of the transmission unit to propel the sprayer. So this is the CAD model of the developed sprayer. So these are basically it is having two front wheels and one rear wheel. The two front wheels are powered wheels used for propelling the sprayer, and the rear wheel is used for handling and for the steering purpose. And the level it is correctly leveled here. And this is the different view of the developed sprayer. And this is the specification of the developed electrostatic sprayer. So the weight including the tank is 105 kg, and as I mentioned, there are 4 numbers of electrostatic spraying units. So single unit was developed, and after that 3 extra units were developed. So coming to the spraying system, so the spraying system diagram is here. So this is the appropriate machine parameters which are considered for deciding the size of the pump and the number of nozzles. So this is what the selected parameters, and the details are given. So the boom weight was 200 cm, and spacing between nozzles were kept 65 cm, considering 30% of spraying overlap, and tank capacity was 50 liter because to avoid refilling of the tank during the operation. This is the power system. And so basically from the battery system through motor controller, the power is coming to the DC motor, and there are 2 steps of speed reduction unit. First is through the chain and sprocket, and second one is through the worm gear. So after that, from the worm gear, the power is coming to the power shaft or the clutch shaft, and then to the 2 duck clutches the power will be going. And from the clutch shaft, to the chain and sprocket unit, it is coming to the axle of 2 wheels. So this is the selected DC motor details, and this is the battery system. So this is the experimental plan for the field study. So for the independent parameters of forward speed, charging state, and locations on the plant canopy. So for that, water sensitive peppers were placed at 4 different locations of groundnut crop, and this is the after spraying image of the water sensitive pepper at both charging and uncharged conditions. So these are the graphs. So first is the droplet density versus the forward speed. So as can be seen, the droplet density were decreased with the increase of the forward speed, and of course charging the spray increased the more number of droplets on the leaf surface. And this is VMD versus forward speed at both charged and uncharged conditions. So VMD of the uncharged was higher as compared to the charged because charging that will result in the repulsion of the droplets, so that will again avoid the merging of the droplets, so which will result in lower VMD. And this is NMD versus forward speed at different charging and uncharged condition. And this is the area covered by the droplets versus forward speed again in charged and uncharged condition. The charged condition again result in more coverage area because of the increase in the number of droplet density as well as in the droplet size. And this is the UC versus forward speed. UC means uniformity coefficient. So charging resulted in better homogeneity among the droplets. And this is the RSF, that is relative span factor versus forward speed. So this is the T test which was conducted to see whether there is a significant difference between the 2 groups in the charged and uncharged. So from that we concluded that charging is having the impact on the droplet size distribution, and charging overall improved the droplet size and distribution. And this is the field efficiency versus forward speed, and with the increase in the forward speed, the field efficiency was increased, and also the power consumption increased with the increase in the forward speed. So coming to the conclusion, the self-propelled battery operated electrostatic sprayer was developed for the ground crop, and the effect of different parameters such as charging, forward speed, and crop canopy was studied on the droplet size distribution. So from this it was observed that charging the spray that performed better than the conventionally uncharged spray. So that's all. Thank you.
What type of fish can diseases are found on the ground network?
So it was when there was yellow spots were found on the groundnut leaf. And during that stage only the pesticide was sprayed. Sir? That is disease.
Any query? Yes, sir. The main thing which separates any spray from electrostatic spray, how you are deciding that your droplet is charging, on what basis?
Sir, before this study, there was another study which was conducted in the laboratory. So in that, we actually measured the current which was carried by a single droplet through electrometer. So electrometer showed the current which was acquired by the droplets. So from that only we got to know that okay, this is carrying some current or some charge.
What is that which you are deciding? Because that is one charge to mass ratio.
Yeah, charge to mass ratio.
So how much charge to mass ratio you got? Because it is not in your results.
Okay, that we have already published in a paper.
So what is the value you got?
So the maximum we got around 18 millicoulomb per kg. 18 to 20 millicoulomb per kg.
Another thing is about droplet distribution. It's not only that how many droplets have fallen on the top surface. The basic advantage of electrostatic spraying is that you get more droplets on the back side of the tips. So what is that ratio? If you got it from Dexel to Dexel cycles, what happened to that ratio? Of droplet distribution.
You can explain it
Later on also.
Later on also.
But you keep it in mind.
Okay, one thing I want to know, what was the discharge time of the batteries or endurance time when you are using it with the ESS?
Sir, we operated it around for around 1 hour from the our main laboratory to the crop site, and we operated there for 1 hour and again came back to our laboratory, and the battery discharge from 24 volt it was up to 20 volt.
20 volt you can't use it. So it should be 22. It will be fully discharged.
What is the principle of charging you have used? What is the principle of charging you have used for charging your droplets? What is the principle you have used?
So induction charging.
Induction charging. So what is the amount of charging you are providing to the this ring, electrode ring?
So voltage you are talking about.
Yeah.
So we have optimized the parameters and came around 2 kV, 2 kilovolt.
Too low.
No sir, for induction charging that is the benefit of actually induction charging. It can be operated in the low voltage also.
तो आपका चार्ज तो मास रेशियो कम हो जाएगा।
हाँ, CMR कम।
No sir, actually.
आप जो 18 बता रही हो तो पॉसिबल ही नहीं प्रैक्टिकली।
No sir, it depends on the droplet size also. So charge to mass ratio depends on various parameters, not only on the voltage, different variables.
It can be discussed later on.
The voltage of fully charged battery.
Yes, it was more than 24 volt and it was full charge.
You are not here or you are not here to more. And then you are coming back to some value. With duration it reduces. So that you should another one point in your presentation. Somewhere you are using SI unit. Somewhere you are using British. So I think you are emptying a PhD scholar.
PhD scholar.
So I think this thing you should have one unit.
Thank you, sir. So, Venkata, you have done good work, but keep in mind.
माइक सिस्टम चेक कर बोलो आओ because online people they can understand only through other way. आदि नहीं है Chapter 5 is सर ये शुगर केन बेल्ट है तो यहाँ पे जो लोग हैं अच्छा लगता है कि
Good evening to one and all, respected chairman, the Harris, and all the delegates there. I am here to present the performance evaluation of micro-operated banana studio. So this is the prototype which has been developed, micro-operated banana stem shell. Yeah. So this is the main features of tractor-operated banana stem which was developed by ASM and Rauri. So this is a 45 HP tractor-operated. So useful for the disposal of banana sugar stems after harvesting of banana. Provide organic manure and mulching in the form of sharp small pieces of banana stems. And effective field capacity was found to be 0.20 hectare per hour with 82.36 field efficiency. Net saving of this machine was worth rupees 18,381 per hectare, and 84% over the conventional method. So it saves time, labor and money over the conventional methods for banana sugar stem shading. So this is the performance of that machines. So we already explained about that. So total area covered is 8.23 acres and effective field coverage is 0.20 acres for outfield efficiency 82. So this is the field operation by this machine. So this is the these are the design considerations. So prototypes, isometric views. Overall dimension of that machine. The test result of that. The conclusions, effective field capacity of the shell was 0.20 for all this field efficiency 82.9%. And net saving of that machine over the conventional method, that is the 84.3%. Thank you. Video. This is the, so actually this is on-field operations because it is a major challenge of sugar stem after harvesting. So it is directly shaded in the fields and after it decomposes it becomes as organic manure.
Which gear?
Yes. So 1.52 km per hour speed. It depends on the size of stem it can be used. But here we are using 2 km per hour speed.
L1
Yeah, L1
1.5 is L1.
1.5 kilometers per hour.
Yeah.
No, but how much is, my question is, how much
Size.
voltage is not working?
Actually that is setting off. Not
What is the efficiency, how much is left or not shredded, left over, and that, because we are indicating the build capacity and the efficiency. Build efficiency.
Stem height.
Not the work,
Double height.
quality of the work.
Sir, from it is hydraulic lifted. Also from 1 inch height it can be cut. And
When you evaluate it, it is not like 100% of the experiments.
yes, not
Some of them will be left out.
yes.
So those efficiency and those data should come out.
We have
You have
calculated.
seen in your video itself.
So we have calculated after harvested material, not inside that the soil.
Top of
Top of
Top of
the
that.
body.
Some of the process will be left.
Actually, what is the size of that shredded material
Chips,
and what is the time?
Just like a gardening and implementation करते हैं, अभी density निकालते हैं.
So sizes is 20 to 25 mm sizes.
You may be guessing, but
Shredding efficiency we can say. Okay, thank you.
Thank you.
Myself Dr. Sanjay Bhamre, Assistant Professor from Machinery. My topic is performance evaluation of data power operated groundnut steamer. So this this groundnut it contains mainly oil, proteins, carbohydrates, and
You just skip the intro.
So the machine and what the parameters of it.
Next, this is the isometric view for developed power operated groundnut to stripper. Single HP motor is used. Two rollers are used for the stripping of groundnuts. This is the flow chart for stripping operations. There are two independent parameters and 5 dependent parameters are taken for performance evaluation of these groundnut strippers. This performance evaluation stripping capacity calculated of this 3 RPM and 3 feed rates. So this chart shows the speed versus stripping efficiency. Here the speed increases, the stripping efficiency also increases up to 350 RPM, and in 400 RPM the stripping efficiency will be reduces. Then these performance evaluations on the stripping capacity, then feed rate versus cleaning efficiency. Cost economics. The cost economics for developed power operated groundnut strippers, the total operating cost of this 1 kg of pods by machines rupees 1.1 rupees, and cost economics by hand 6.25 rupees per kg of this pods. Summary of conclusion: the groundnut stripping capacity of this machine is 178 kg per hour, feed rate is 480 kg per hour, and speed is up to 400 RPMs. And the maximum cleaning efficiency was observed in 350 RPM, and feed rate is 360 kg per hour, and damage of pods percentage are observed in lowest feed rate 240 kg per hour and RPM 350. Then the cost of stripping 1 kg of this machine and hand operated. This is the stripping capacity of machines. All parameters here is saving time, machine save, the cost of these machines. These are the references used for this development. Thank you.
And for this particular variety,
variety any variety is used, but in these machines performance evaluations the preliminary variety is selected.
compare tested okay, compare
comparison with variety.
Which type of plants? Valencia type or groundnut or second type or Valencia type? Spreading type or plugging type?
Plugging type.
Manual means what?
Manual is stripping the pods and back using the hand.
But I think there are groundnut strippers.
Many types of groundnut strippers.
Count type.
Three types.
Now
this machine comparison with other machines you will be better.
Now the traditional is also changing. Now this traditional or conventional comes to the at least because the V-shaped rod is used for calm type. Slipper are being used for last 20 years. More than 20 years,
Actually, this is the four-station machine. At a time, four persons are working on that machine, and here we use the stripping mechanism is changed. Instead of V-loop, we are using rod.
So, not necessary for one can also be used. There are four, maximum four can be more capacity. Even a single person can also do this stripping. Based on that, if compare, then also even in cost of coming also, you have to make this value of the losses efficiency 96-97%. Whereas in case of manual, it may be 100%. So the 4% cost of the groundnut is added into the cost or not?
Cost is added in machine total cost. My only suggestion to you is that most of the time you use the decimal places to do, like your cost of machine will be 0.27. Maybe for you 27 paisa is there, but others it will not be possible. You will not be getting the things from paisa or in your 1.0 like that. So please try to, that will never be achievable next time. Even if you don't do yourself, you will not get that value. So then getting such value has no meaning. Report value which others can also achieve. It cannot be 1.11111 like that. Has no meaning. 1.1 is sufficient.
And yes, I am
Simple calculation doesn't make it hold any ground.
Every person is using EHR and
This use one unit. This take into this thing. ना आप कहेंगे 0.005 हेक्टेयर पर आवर, it has no meaning. 0.4555 वो आएगा ही नहीं अगली बार. आप खुद करके देखो.
Actually, the rounding off should be there.
Reasonable rounding off should be there.
At least for Dr. Kamle,
आला आज माझ्याकडे आता आले 5 वाजता पेपरून नाही सर माहिती का नाही उद्या आलं पण तुम्ही घरी दिलं नाही लवकर तिचा डॉक्युमेंट आलं माझ्या डॉक्युमेंट नंबर यायला नंबर आला होता चौकशी जाऊन ते आलं नव्हतं दुपारपर्यंत आलं नाही आता कॉल करतो आलं की नाही तिथं कॉल असं आलं मी तुमच्या बाजूला घेऊन येईल उद्या तिथे गाडी गेली पुण्यात मग घरी आले मी सुद्धा बाहेर होतो मी घरी डॉक्युमेंट ठेवलं होतं डॉक्युमेंट नंबर घरी देणार माझ्या घरी आले
The objectives of this study are to design and develop tractor operated for the stable and to evaluate its performance. I'm skipping the introduction part. These are the commercially available shredder. But it has been observed that the commercially available shredder have got the shed order stock from 250 to 400 mm and hence the standing service are available asset in the field. And a shredding of stock is partial solution for the crop residual and that is why we design here. These are the configurations. This one is the commercially available shredder and just behind it we have installed we have developed the cotton stable operator for 2 rows. This is the specifications of the attachment, and we have used here the commercial developer shredder, and we have taken here the measurement of drop as well as this kind of our requirement. We have used here the for the cotton plant, and these are the properties of the cotton. We also have recommended. From the study, a drop requirement was observed before. We have taken here the notch disc as well as plain disc, and depth of operation we have varied from 150 to 150 mm, and we have operated for 0.5 km per hour, 3 and 3.5 km per hour. And we observed that 460.37 kg drop was observed in notch disc, whereas 493.41 drop was observed in plain disc. These values are from the past report. As far as the stable operating efficiency was observed, at 200 mm depth of operation, almost about 99% the stables were uprooted by the notch disc. That was also within the range. Fuel consumption was observed 5.97 in the plain disc and 4.78 liter per hour in notch disc. We have also taken the observation for individual disc width of operation. The field capacity was measured here. The effective field capacity was also 345 hectare per hour, and field efficiency also around 83 to 84%. This is the cost economics of the shredded with brutal attachment and the traditional practice by V plates. It has been observed that the cost of operation is 2,480 in case of the shredder with brutal attachment, and traditional practice it was to be 3,400. The cost of saving was also to be 27.03% of the traditional practice. This is the field condition. Competence. Total plant shredding, stable operating, and strip blowing. These three operations are performed in a single pass of tractor. Two rows are covered by the developed stable operator attachment, and hence the field capacity was found to be 351 hectare per hour. And the depth of operation 200 mm was sufficient to operate almost 10% cotton staple, and saving in cost of operation was observed to be 27.03% for traditional practice of cotton staple operated by V plates. Thank you.
Any query from you?
What is new in it?
Sir.
What is new in it?
Actually, sir, notch discs are also available, sir.
Not available.
Available, sir. We are just combined with the shredder, sir.
That has also been done.
Shredding actually.
Come mixer.
It is mixing of the stubble or
The commercial shredders are there, but they shred the stock up to the 200 mm to 400 mm they are left in the field, sir. So I try to get it uprooted also, sir. As we have also tested the MPUT design also in our field. Dr. Deshmukh madam is also there. Comparatively, the efficiency of the field efficiency of MPUTs was 50% than that of this developed, because it is only for the single row. We have designed it for the two rows, sir. Sir.
स्लीडिंग करने के बाद उसको अपलोड कर फिर उसका क्या
how actually that was the question. I am also having that question. अपलोड करने के बाद सजेशन करना है।
नहीं सर, तो चला जाएगा सर।
So it is mixing.
बायोमास यूज नहीं करते, अगर उसको वैसे छोड़ देते तो भी वो ऐसे समझा
स्टैंडिंग रहता है।
निकालना पड़ेगा सर, उसको बाइक करना पड़ेगा या फिर पास से
Can we have no attachment to collect that stuff? Actually वहाँ पे प्रॉब्लम हो सकता है, वो As temporary problem may be there, that can be avoided.
सर जब ये कॉटन स्ट्रॉ नीचे से अप्रूव हो जाता है ना तो यहाँ पे 46 डिग्री टेम्परेचर रहता है तो पूरा वो ड्राई हो जाता है उसको नहीं होता इधर वो अपने कंडीशन
Somebody was last person to speak, na?
Thank you, sir.
Next issue, so he was asking for the. Okay. Sir, Wallet, sir.
Online people are there. Finish with.
This is Sani. 26.
अरे आप लोग तो पी ली हम लोग तो भी नहीं यहीं से रुक गई
कैसे कह दिया कि मैंने पी ली
मैं देखा
मैंने साहब ने बोला नो शुगर के चक्कर में साहब ने
चीनी वाली
ओके
Good.
नीचे रखते हैं और दूसरे पी के भाग जाते हैं, हम लोग बोलते हैं नीचे रखते स्टूडेंट वगैरह पी के
A very good evening to one and all present here, respected chair, director CIA, and all the delegates from across the country. Very warm good evening to one and all. So I'm going to present the topic development of girdling tool and chemical injector for leaching cultivation. This is one of the collaborative projects with CIA and NRC Lychee Muzaffarpur. Everybody who loves lychee, right? Lychee is so delicious, tasty fruits, but because of the climatic restrictions, it is grown in mostly eastern part of the country. And if you see the mechanization status of
Go to your wife.
I'm just coming.
So next session, next session.
So if you see the mechanization status of lychee, there are several mechanization needs. So I have targeted two. One, the bark eating caterpillar killing is a big problem, and for that they are using hand cycloscope and all. So I have made a hand tool for this, and then girdling operation. For that we needed a motorized one, so we developed that. So girdling is might be new to us, but girdling is a selective wounding process. What we do here is there are plants, nutrients are transported with xylem and flowing vessels. So with the xylem vessels, everything from the roots goes to the other parts of the plants and leaves. And after that photosynthetic process happens, and photosynthetic whatever is produced in photosynthesis process, that goes across the plant from the top to the leaf to the bottom roots. So what we do here is we are making a wound. We are making a wound so that the photosynthetic part cannot go to the root zone. So by that process, what happens in the upper portion of the plant, above this, there is a better carbon-nitrogen ratio, and thereby fruitings comes. The flowerings are better as compared to the non-girdled trees. And there are several advantages like increased fruits, yields, and you can see the lychees are generally comes in once in it, but by this process it can be in the branches. So these are the girdling requirements we found, and like we need to do in between September to first week of October. Actually, we can do in several fruit crops this girdling operations, but we need to find at what time we have to do it. And people have found it like September to first week of October we have to do, and we have to do like 75% of the branches, and year by year we need to do like first year, second year, third year, and this is a very time cumbersome process, laborious process. So this is the traditional process by which you have a knife and you do it, and these are the process by which you do, and it takes around 10 minutes. And also we wanted to mechanize it, and we have developed a motorized girdling tool with the blades, with the arrangement that it cannot go more than 3 centimeter depth, and we have used motorized one, and then batteries are there, and which we are using from last 2-3 years. We have given it to the NRC leadership people, and they are using our videos also. So we will be playing last, and these are one of the by the manually done, and this is the girdle with the machine, and these are the thickness. Time is up to like within 3 minutes. One girdle can be completed. We have done girdle ergonomic evaluation as well with the machine, and we found like the parameters are lower, like discomfort level are lower with the motorized girdling tool than traditional practices. And another problem which we targeted is like there are like caterpillars in most of the fruit crop, particularly in lychee, pear, guavas, that these caterpillars are living inside the hole, inside the branch, and in the night it's come out and then eat and eat over the branches. And when you spray, because it is inside in the daytime, so you cannot kill them. Even you spray, you cannot control. So what we do is, what farmers are doing is, people are putting kerosene inside it and covering it with the mud. So we wanted, this is the problem. So we have developed a motorized tool again with the battery system, tank, nozzle, funnels, and then we just go there and fill this. So it's like we have used a battery of 7.2 volts. Application time is less than 1 minute, and operating period is, I mean, you can operate one machine for 3 hours with one charge. So conclusion is, we have developed 2 machines, 2 small hand tools, which is performing as per script in each charts. Girdling for girdling machinery, girdling is like less than 3 minutes, and drudgery is lower than the traditional ones. And for chemical injectors, application is less than 1 minute, and battery life is 3 minutes. Thank you. I have a small video. So this one we were training the farmers. So I mean, for the first time, he's the farmers and he's just trying to do it. So for marking, for the first time, like we don't know how to operate it. So I mean, we have to make it round. So that is how we are making it round. And this is like from the outside you can see. Actually, I'm just showing it like from the outside how it's turned. And there's a remote so to switch on and off. So inside holes and all, you can just do it. Yeah, thank you.
Anybody is having any queries?
No, then thank you.
Thank you.
I have 2 queries. One is what is the weight of that equipment for girdling, and have you tried it for grapes also?
We have not tried it for grapes yet because we don't know time actually. Yeah, if time is there, we can do. As I said, we can do it in lots of crops. And weight we try to reduce. I mean. Less than 1 to 1.5 kg, it's around 2 kg now.
What is the rest period?
Rest
cycle.
I mean, it's not too much like a hectic, so you can continue. Yeah.
And how much is the pressure you are applying for those pesticides inside the?
I mean,
it is under pressure or?
Yeah, it is under pressure. The height which can produce by the pump is 3 meters in terms of water, so you can convert it. That pump we have used it for up to 3 meters. Thank you.
Sani, only one question. You are reducing the drudgery, but if you are holding a device which is rotating at a higher speed, will it expose the worker to hand-arm vibration?
Because a little bit, but it's like, as I said, currently it is with a knife and we have to do it around.
That is okay.
Yeah.
I'm saying maybe add another occupational health hazard later on.
Because there is a motor and rotating at higher speed, so it
just give it thought to it.
Economic study may be needed.
Yeah, we have done it, but yeah, on that part we will do.
एक्चुअली मुझे वायर का भी क्वेश्चन था कि आप बैटरीज नीचे रख रहे हो।
बैटरी या तो I mean we can put पीछ पे रख के करना है
because it may be intermingled in that.
Yeah. So we were training, so we have to put it in the back and then we can do it. Thank you, sir. Thank you.
This is last now. Dr. Palay,
Yes.
इसके बाद वाले नहीं होंगे ना सर
ये ऑनलाइन का एक्सप्लेनेशन
People are there. Okay.
they must have given yes please sir.
Very good evening to everyone. I am Dr. Ashutosh Mandawar from CJ Global. I am the President Cotton Stripper Harvester for Indian condition. Cotton picking is most important field operation in cotton cultivation, which accounts for 33% of the total cost of operation. In India, cotton picking till date could not be dataless because we did not have varieties which are suitable for cotton picking. Yes, I will take. I have completed 5 minutes. But now the situation is different. We have varieties and defoliant available in India. Our farm size are also lower as compared to other cotton, highly mechanized cotton producing countries. Among the two types of mechanical cotton pickers, spindle type of picker, these are costlier, but these are having lower trash content as compared to other type, that is stripper type of machine. Those are having higher trash content as compared to spindle type of machine. But the machine cost is very low as compared to spindle type of machine. That's why we have attempted to develop a brush type of cotton stripper. Before development of the machine, we have measured the properties of some of the cotton varieties which are suitable for mechanical picking, like plant height and percentage of the fully open cotton plant. So we found plant height less than 3 feet, which is suitable for mechanical picking, and plant fully open plant 85 to 90%. So these varieties are suitable for picking. So based on that, we have designed a prototype experimental single row rear offset mounted machine, brush stripper machine, and try to optimize its performance on the specially developed rail on which we have mounted cotton plants in which cotton balls were opened. About 85 to 90% cotton balls were opened, and try to optimize the performance of the machine with the independent variables as brush speed, forward speed, and brush inclination. So in optimization study, we found that the picker efficiency and trash content, picker efficiency was higher and trash content was minimum at a drum speed of 290 to 310 rpm, at a forward speed less than 1.5 km per hour, and suitable inclination less than 25 to 30 degree. So the performance of machine was optimum at this parameter. Then based on the optimization study, we have did some modification in the machine and developed a single row rear offset mounted machine. And first of all, we have tried it, tested it at a CA farm, and then on the recommendation of regional committee, we have also tested the machine at Central Institute for Cotton Research, Nagpur, in high density planted cotton with Ankur Kirti variety. So these are some photographs of the machine. These are some photographs of the machine field testing at CICR Nagpur. So this is the video of the machine. So this is the video of the machine testing at CICR Nagpur. This is the single row machine. And the performance result at 60% plant moisture content, the picker efficiency was about 93%, at mechanical picking efficiency of 90%, and number of plant harvested with this machine was about 67 plant. In the trash content analysis, out of the total crop harvested, the total trash content was 28.83%. In that bus itself, it contained about 23% of the trash, and rest remaining was sticks and leaves. So I would like to highlight here that there are the machines available which can clean this trash from even from 35% to 3 to 4%. So in conclusion, I would like to say that the effective field capacity of the machine is about 0.1 hectare per hour at field efficiency of 80% and forward speed of 1.35 km per hour. We can increase the field capacity by increasing the number of rows and also operating the machine at some higher speed. And then picker efficiency was about 93%. Net seed cotton output for single row machine was about 150 to 270 kg per hour, as against only 5 kg per hour in hand picking, while trash content increased 29%. Thank you. Yes, sir. We have used defoliant. Defoliant is under preparation, under development at CSL Nagpur, and hopefully it will be commercialized soon. This year also they have promised us to give defoliant for testing.
Single time picker.
Yes, it is a single time picker. All mechanical picker are single time picker. That's why we need a synchronous variety. There are varieties, not exactly 100% balls are open in one time. 85 to 90% balls are opening in so many varieties, synchronous varieties. We are having the varieties which are having short height less than 3 feet also, and compact varieties also. So varieties are available, but only defoliant is not commercially available. That is why the cost of defoliant is very high. That is, I convert that the cost of defoliant is about 4,000 per acre. So for 1 acre we need about 10,000 rupees only for defoliant right now.
Actually, in Akola only,
yes,
they have tried a lot for developing stripper. This is kind of stripper.
Yes, sir, brush type stripper.
Spinner type machine. Only one question from my side.
Yes.
How we can clean the material which is already there, because it is coming with the cotton, it is not separated. The cotton and the bowl both are connected.
So there are some cleaners available, cleaners and
Yes, 38% trash content.
yes, in any mechanical hand picked cotton is always it is considered as the best cotton. Any type of mechanically picked cotton, whether it may be spindle or stripper cotton, the quality of the cotton will be lower than the hand picked cotton. Any type of mechanically picked cotton you get. If we have to go for mechanization, then we have to compromise the quality. Thanks.
So now there's no other query, then thank you. Letter pilot has come back.
You can invite online.
Ask for online. Anybody?
Sorry for disturbance. Let's welcome our Deputy Director of General Respected Dr. S.N. sir to this technical session. I request Dr. S.R. Mehta sir, Director, Central Institute of Agriculture Engineering, and Dr. Senthil Kumar sir to welcome DDG sir with a bouquet.
मैं एक चीज बताना चाहता हूँ, हम कुछ आई कार्ड QR कोड बेस्ड आई कार्ड करीब 250 का डॉक्टर साहब के पास है। किसका है नहीं है नहीं पता। हमारा आप सब डेलीगेट्स हैं।
Thank you, sir. Thank you.
अभी यहाँ पर और चलेगा। आप वहाँ से गाड़ी लेके घर आ जाइए, यहाँ पर दुकानें सारी चीजें आई कार्ड लेके आ जाइए। हाँ कल एग्रीकल्चर में सेशन कर दिया है तुमने चालू ठीक है और वहाँ सब लेके आ जाइए हर रूम में चले जाइए नाम बोल के जाइए जो है उनको दे दीजिए जो नहीं है उनको नहीं दीजिए ठीक है लेके उठा कर लेके नहीं जाना ठीक है गाड़ी वहाँ से लेके जाना तो 200-250 गाड़ी हम बना पाए सिस्टम है लेकिन नहीं हो यदि फोटोग्राफ है सारा ही वगैरह ही है फोन नंबर है तो उसका आई कार्ड QR कोड आई कार्ड नहीं वगैरह तो आई होप that सब काम होगा
Someone from
anybody online, please.
Sir, I'm Dr. Tyagarajan from Legendary Kumru, sir, Tamil Nadu.
Okay.
Can I share my screen, sir?
Yeah. Just share the screen.
serial number 12, sir.
I am the development of tractor hydraulic powered Almira.
Exactly, sir.
Okay, please share your screen.
Sir, it's visible?
Yeah.
No.
Yes, it is visible.
Just, no, yeah, share your PowerPoint.
Yeah, sir.
Make it in a slideshow.
Right, so visible, my PowerPoint is visible, sir?
Yes.
Yeah, your PowerPoint is visible. Yes.
Yes, sir. Good evening to everybody. One and all present over there. So I'm here to present a development of tractor operated Palmyra tree climber for this 15th annual convention held at Parvani. So we are the four project principal investigators and the co-principal investigators. So we all know about Palmyra. It's a basically very fibrous tree.
Dr. Tyagarajan.
Pardon, sir?
Kindly try to complete in 5 minutes.
Okay, sir. Okay, this is a basic. The Palmyra is a very known tree for exclusive for Tamil Nadu. It's also a cultural base or integrally for Tamil people, sir. So it's a very highly respected in Tamil culture, integral part of Tamil life. And for Palmyra tree is also ecological, medicinal, economical and social benefits to society, including preventing soil erosion, protecting natural wealth, withstanding adverse climatic conditions, withstanding natural calamities and providing eco-friendly farm products. It is also known as in Tamil called Panai. In Tamil Nadu, it's a kalpatru, which means that it's holy tree where all the part can be used for all the tree part can be utilized. So this is the basics, the introduction of Palmyra. So at present, sir, we can find different types of Palmyra trees are available. Usually the Palmyra climbing method is only for manual climbings are mostly preferred, and there are some little type of machines are available for climbing the trees, like manual operating climbers. So that is also, but it is not much satisfied for the farmer because it takes long time to fix it and attach and detach it. So minimum it takes 5 minutes to attach and to detach this machine. So the people are not utilizing properly of these machines and technology. And manual climbing is also declined. So due to this decline, the total trees are get completely cut by the people in and around Tamil Nadu here. So for this purpose, I have developed a Palmyra tree climbing device. So for that, I have made a survey in our place where the more Palmyra tree climbing trees are grown there. So you can see the Palmyra tree, you can find there the grip of the Palmyra trees are varied in single trees. The single tree you can find the grip is changed in the down and middle part, slightly goes up, again goes big, again slightly goes up there. You can say different diameters are available. This is the main problem where it cannot be machines or get succeeded here. So we are considering these factors. I have taken a survey by considering 50 numbers of tree, measuring only the height of the grip, diameter of the grip of the tree, only above the 4 feet. So where I can fix my tree climber and then I can be climbed. So this is the methodology we adopted. From that we have basically developed a tree climbing device. So this is the assumptions for design consideration. where operators weight and time is assumed to be applied at product centroid as downward first, where you can see the total tree climbing device has an effect so that it has to take the operator 100 kg. 100 kg along with the tree climber with almost 150 kg. It has to go up and it has to come down. So from the calculation it is found that almost it requires a torque of 73, at least 74 Newton meter torques are required for this. So for that what we have done is we have selected hydraulic type. Hydraulic is a power bolt here. So where hydraulic motors are mostly used for this, we developed with the tractor hydraulic to climb vertically without any slip. So this is the basically a developed machine. So you can find advantages. Why we went for hydraulics is because hydraulics advantages are high torque. Hydraulics create more high torque, enabling lifting heavy loads with easy operation. And second one is precision and control, smooth and very precise control of movement, crucial for gradual and controlled motion that tree climbing. And
kindly go to your project methodology directly and results. That will be better. Because it is almost 4 minutes, so 2 minutes are there only.
Right, sir, my voice is audible?
Yes,
this is the Palmyra tree climber which we have developed. We have the mainframe and we have two rollers. One is upper roller and lower roller, and a gear mechanism which we used a dual gear mechanism at two ends of the roller to have the same speeds in the two rollers. And we have guiding wheels as well as gasket for automatic grip adjustment and use hydraulic motor motors here.
Can you show any videos available, sir?
Yes, sir, yes, I'll show you. And come to the video, you can see the video here, sir. This is the machine which can climb without any operator, sir. So directly it operated the tractor hydraulic, where the machine goes up and down. It's for just for video, so video purpose it's being shown here, sir.
डायरेक्शन चेंज हो रहा है तो आदमी बैठेगा तो और
उन्होंने किया
So I can show other videos, sir, with human beings, sir. It's carrying full completely almost 60 kgs of human along with the tree climber, sir.
hydraulic में रिस्क होता है if it is clear
पैर उसका दोनों पैर के बीच में सीट आ रही है साइकिल वाली सीट रखे तो ठीक बैठोगे
सही है
नहीं कर वो ड्राइवर वो जैसे पूरी साइड पे होगा
नहीं सेफ्टी का इशू है
सेफ्टी के वजह से
वेरी डेंजरस
You can find this machine. It goes up to the ground area where the machine. The operator is able to clean the ground, complete the ground of the Palmyra tree, as well as he can harvest the fruits also, sir.
Please conclude.
You can see, he can standing on the machine, and he harvesting the fruits.
Sir, kindly conclude the.
Yes, sir. Yes, sir. Yes, sir. And this is the result, sir. So we from the evaluation we find the climbing time for taking for one tree, that is we concluded that we found that 1 feet per second. If it is 40 feet, it takes 40 seconds to climb. Again, reverse speed is very less when compared to climbing speed, sir. So this is our final conclusion, sir. So cost of is very higher when compared to conventional method, because conventional method as well as tree climbing method, since it has a cost of tractors, additional cost for us, sir. So tractor will take $600 and total tree 110 per hammer for 3 climber, develop 3 climber. So the harvesting capacity is 32, number of
Hello. Are you there?
Hello.
Dr. Tyagarajan, are you there?
He is there, but
I think you have become muted or something.
No, muted नहीं है, network का issue है.
Thank you, sir.
नहीं, muted नहीं है.
Thank you, हो गया था.
Okay, then we stop here because there is some network issue. But it is still be showing.
Kindly unshare your presentation. Dr. Tyagarajan. Okay.
Okay, then
Any questions from any audience?
later on we will take the question because the person is not available, so he may not be able to answer. Anybody else?
Any online presenter wants to present? Come. Mango harvesting tool. Hello, Dr. Kamraj, can you hear us?
I think there is some issue of your microphone. Please check your microphone.
Ask for unmute.
Sound is not coming. Please check your microphone, please, because your voice is not coming to us. Making it on and off, but it's not coming. So, Dr. Kamraj, please answer. We will take you back. Anybody else? All right.
No, he is here. That one.
Okay. Also found the if nobody is there, then
You'll wait for
इनको आप डिलीट कर दो, रिमूव करो, फिर दोबारा जुड़ेंगे तो हो जाएगा. अभी क्या है ना, नेटवर्क की प्रॉब्लम है. शेयर भी कर रहे हैं, ऑडियो नहीं आ रहा, एक बार रिमूव कर दो,
रिमूव करने से
रिज्वाइन करने से
रिज्वाइन कर सकते हैं क्या?
हेलो
सर. Yes, please go ahead.
Good evening, sir. Sir, my tool is fruit harvesting tool, sir. So, pretty automatic fruit harvesting tool. Before developing, so I conducted the survey in Periyapuram College, College in Periyapuram. There are 20 members, the age group of 30 to 45 years old. So, by hand and the existing tools which are available in the market. So, in this, the tool is used very easy, so no discomfortness. And so the average height of the tool, existing tool is 4.2. Upon 1 acre, depends upon the fruits available, the 2 laborers is need. So every 1 hour, they want to take 15 minutes break. So first I developed the model, first model. So in this, the cutting section is circle shape and end the cicator is scissors is used. So the scissors connected with, through this cable wire. So in the bottom, the TVS 50, the clutch is provided. That's a lever, clutch lever is provided. With the help of this clutch lever, the power is transmitted with the scissors. So then again it's conducted trial in this formal speed. The identifying these fruits and locating the fruits is very difficult to cutting section which is having this circular section. So again I modified the triangle section with the help of the same scissors. So in this one modification, the first model, the square pipe is used unable to hold this tool. Then this circular section and this lever, the operating lever is 360 degree, you can rotate. So depending upon the operator's convenience. This is a model 2 developed. Then again it conducted trial speed. So based upon the farmer's need, so I developed a battery operated automated fruit harvesting tool. So it is having this the telescopic pole. We can adjust the height of this tool 3.2 to 4.2 meters. Then provided the bottom box, white box is provided. Then top, so one more is provided here. This is a receiver, this is a transmitter. So the transmitter which is having this four batteries. So with the transmitter 320 kilohertz. It can transmit around 25 meters from receiver to from transmitter to receiver. Then the cutting unit and cutting basket is provided here. Then the conveyor net. So after removing this basket, we can use the conveyor net, which is conveying fruits from this top to harvesting place to bottom in the bottom. So this is the different heads of cutting units. So here the arm transmitter module, this is a circuit, this is a transmitter module, this is a receiver module circuits are provided here. Then the conductor survey, these are the results, the modifications model 1, 2, 3. So here the first, the operating wire, the model 1. The operating wire is 800 kg.
Sir,
then
please come to results and discussion, that will be better.
Okay, then it's a different places I conducted demonstration on trial. The first in front of White Charles I demonstrated. Then Perikulam Campus Horticulture College, Perikulam Horticulture College and Trichy, then State Horticulture Farm, then the students in front of horticulture students I demonstrated and taken the readings. It's a result. So in the model 1, model 2, model 3. So in the model 3, the fully automatic model, around the 400 mangoes are harvested per hour. This is the results. Since the easiness of operating tool is model 3 is very easy. So no discomfort. So the fruit, so no damage. Because the existing models while harvesting the fruits, it damages the branches as well as unmatured fruits. So let's show one video, sir.
Please. If you have videos,
share first this one and then operate that video.
Oh, yeah.
No, it will not operate from there.
Then this is the first model. So first the cutting end having these secateurs or scissors. They above the operating wire. This is provided. So this effort we can harvest and pick the fruits without any damage of unmatured fruits and the branches. So next one is the second model, the triangle cutting sections. The same scissors provided. Then the hand, the operating lever is it can rotate in 360 degree. So operator convenient, they can adjust or change the position. The next one is third model. This is the receiver and transmitter provided. The cutting unit having this DC motor. So 350 RPM rotations. So with the help of 4 batteries, the motor is operating receiver and the transmitter.
Thank you, Samraj.
Okay, sir. This is based on the request of this farmers. Is a convey net is provided to reduce the damage of fruits when the falling in the ground.
Okay, sir.
The collecting, so replacing the collecting baskets. Otherwise, he needed to empty it after an harvesting of 5 to 7 fruits. So further reducing that time to use the conveyor net. It reduces the harvesting losses and damage as scratching the liquids. It enhances the overall harvesting efficiency and capacity. So no physical and health problems to labor. So it's very easy to operate because the weight is only 1.8 kg. The harvesting capacity 400 kg of fruits per day. Thank you, sir.
My only suggestion is that you ask the laborer after working for full day what happens to its shoulder and eyes. And then come back with the economic evaluation of it. Don't talk about those things.
And pull
the coal harvesters are popular for last 20 years and it has never become popular. You know, this kind of harvesters were developed almost 20-25 years back. And till 25 years, today also, these kind of harvesters never became popular. The only problem that happens is that the person's ability to hold and look at the top constantly for 1 hour or 1.5 hours, keeping your arms up, shoulders, is very,
It is highly recommended to high density planting.
Don't think about high density. I am asking about the man who is going to harvest it. Please check it with that. Only doing it for 15 minutes, 20 minutes, it is okay. But when you do it for whole 8 hours in a day, you can imagine.
Yes. So excuse me, sir. So for that we are doing the mobile operating. So with the help of this mobile vehicle. So on that it will fix on that for reducing the labor drudgery. That's why we are doing from here. The next
check it
and continue the project.
Okay, thank you.
Suggestion is that make a ergonomic evaluation and then present it. It's okay. Thank you very much.
Okay, thank you, sir. Thank you, sir. Welcome.
Sir, maybe it is suitable for drawer or what?
Up to 2 meters, your height is sufficient. 1.5 meters. Is nobody is there? Is there anyone? Dr. Palet has come? Not yet. So, in this session we had 9 presentations. Only 2 online presentations and 10 offline presentations. So, very good number offline presentations. I thank all the presenters. My co-chairman, host for my chairman, the other fellow, Dr. Navai. I thank him also. Thanks to all the deputies. Thank you all.
At the outset, I thank both the chairpersons, Dr. K. Nagarwal and Dr. Sachin Nalwade. So I would like to thank both of the chairpersons with memento. Also, I thank both the reporters, Dr. Gopalkar Pandit and other reporter. Thank you, Manada. Thanks for the presenters.
चार लोग हो जाइए ना, बैठा इधर देखो आप। Thank you, sir. Thank you very much.
The next session, I think we will start another couple of minutes. So before that, all the presenters, please load your PPTs. So that please load it. I think most of the people, more number of presenters are there. So please load it to avoid the.
So it will be long session.
Sorry.